Good morning बच्चों. Today we will learn about new experiment polygon of force apparatus. In this apparatus, what is the aim? The aim is to verify the law of force polygon. You might know the law of force polygon that if it is system means at a point more than two force acts. See here, two forces acting, and here more than two forces acting. More than two forces acting at a point, here are 2 points and whole system are single system, and if it forms a polygon, then the closing side will represent the resultant of that system at this point and this point. Now we will draw the line diagram with the help of this shadow and pencil and scale. See, this is the line of action of force, this is the line of action of force, and the reaction force acts in this direction. The action force is here, and its resultant will act in this direction, and its reaction force will act in this direction. Again, for the next point 2, force acting downward in this direction, again in this direction and this direction. Its resultant will act in this direction, and its reaction will act in opposite direction. So each force system having some names. This force is F1, F2, F3, F4 and F5. So F1 have some magnitude. This is 100 gram F, 100 gram F. Overall 200 gram F. F1, F2 is 150 gram F. F3 is 100 gram F. F4, this is F4. F4 is 100 gram F, and F5 force attached with the pulley system. F5 is 200 gram F. So this is the force polygon apparatus in which 5 forces are acts, and we are going to verify the law of force polygon. Now with the help of pencil and scale, you have to draw the line of action diagram with the help of shadow by seeing the naked eyes. See, it is forming many shadows along the length of line of action. So you have to consider one shadow at a time, and you take that shadow reference. Now see, I am considering this one shadow, this one. I have given one point. Now see, the line of action is like this. I have drawn this force is F1, its magnitude is 200 gram F. F2 force vertically downward, its magnitude is 150 gram F. Now the resistance in a reaction force, yes, up to here. One force is acting vertically downward, this is F3. Again force is F4 in this direction. With the help of looking shadows, this force is F4 and one force is F5. So these are our 5 line of action diagram of this force system, and you have to name all the forces. F1, this force is F1, F2, F3, F4 and F5. And taking out this chart paper, you have to draw all the angles between these forces. It means angle between this. What is the angle between this forces? This angle, this one and this one angle. And after measuring the angles, we will construct how to calculate the resultant forces. So after calculating the line of action diagram in the chart paper, now coming to the calculation portion. This is our the line of action diagram. I have already told you that force F1 is 200 gram F, F2 is 100 gram F, F3 is 100 gram F, F4 is also 100 gram F, and F5 is 200 gram F, F2 is 150 gram F. Okay, this is the internal forces, means reaction forces acting in this direction. Whole system are in equilibrium, and the name of this apparatus is force polygon apparatus, and you have to verify the law of force polygon. Before coming to the calculation portion, I want to tell you some terminologies about the force. Force is a vector quantity, and it have both magnitude as well as direction, and its magnitude is represented by length. So by using this concept, means magnitude is represented by length of vector, we are going to construct a polygon. Now see, F1, F2, F3, F4, F5, we have retained this. This is the force and its magnitude 200 gram F, 150, 100, 100, 200 gram. Now what we are doing, we are scaling down this force. We have taken the scale 50:1, and we are dividing all this force by 50. 200 by 50, 4, divided by 153, divided by 100, 2 cm, divided by 100, 2 centimeter, again by 200, it is 4 centimeter. So this is our scaled length. Now we will take this scaled length and draw the force polygon. So now see, this force is F1. No, come to the force F2. First of all, come to force F2. F2 is how much? 150 gram F, means 3 centimeter. Reference lines, we have drawn a horizontal reference line, and from one point, means this point is 1 and this point is 2. From one point we draw F2, how much? 3 centimeter vertically downward. This is F2. F2 how much? 3 centimeter. Okay, we have drawn the length of force F2, means 3 centimeter will represent how much force magnitude? 150 gram F. Now with the help of principle of transmissibility, we will transpose this force into here. What this principle says, that without changing the direction of this force, direction and magnitude of this force can be shifted towards this line. So first of all, we take what is the angle from vertical. There must be some angle, let it be alpha. We also draw some line here. Now we shift this force about this point, F1, without changing the magnitude and direction. This is F1, and angle from vertical is alpha. This one representing here F1. What is the angle from vertical? This alpha. Okay, force F1, F2 we have considered. What will be the length of force F1? 4 centimeter. Now the closing side will represent the polygon. You know polygon is a region bounded by 3 or more than 3 line segment. Here 3 line segment comes. The closing side representing the resultant. So this is R1 centimeter. Whatever may be the line, this is the resultant at this point, and whole remains the same single system. Now we are coming to the second point. This point is second. Now see F3. F3 is acting vertically downward. F3 force is 100 gram F and its magnitude is 2 centimeter. We have to draw 2 centimeter from point 2 vertically downwards, and again with the help of principle of transmissivity we will transpose this force F4. We draw vertical line here, horizontal line, you draw horizontal line here. What is the angle between horizontal line? Means reference line. You take alpha 1. Whatever may be the angle, you have to construct with the help of compass and protractor. That is alpha 1. Here is also horizontal line. Take the angle and draw F4. F4 how much? 2 centimeter. You draw F4 2 centimeter in this direction. Again what for F5? See, F5 is at some angle from reference lines. Suppose this is beta. You again draw one reference line, and this F5 can be transposed up to here F5. This angle is beta. Okay, all this force F3, F4, F5. F5 how much centimeter? 4 centimeter. You have to draw 4 centimeter from the end of F4. Now tail head equals to head tail. The closing side will represent the resultant of this force system acting at point 2. So here is resultant R2 centimeter. R1 and R2 must be same, but ये same नहीं आता है. And the reason for not coming same is that there are pulleys. We have seen the pulleys. 3 pulleys are acting in force polygon apparatus. Pulley comes and it comes with the friction value. So due to friction, energy getting dissipated and the resultant value are not coming same. There may be 5 to 10% error, and we have to finally find the error between resultant and its direction. And one more thing, that hold this system are at 2 different points, so you have to take the direction wisely. Suppose this left, if you take left anti-clockwise, then you take right as a clockwise, or left as a clockwise, तो right का होगा anti-clockwise. We are taking here anti-clockwise. Suppose this is angle of resultant with reference line, it is theta 1, and this is anti-clockwise, so you have to take for this clockwise. This is clockwise direction, this is theta 2 angle. This is the angle between resultant. Now you have to find percentage error of resultant value, that is R1 and R2. What comes? Mod of R1 minus R2 by R1 multiplied by 100. This is the percentage error in resultant. Again in direction, theta 1 minus theta 2 by theta 2, theta 1 into 100. This is for the resultant. So from here you can find the percentage error, and it comes 5 to 10% both approximately. From here you can say that law of force polygon is verified, and the reason for some certain error 5 to 10% is the pulley. Now this system can be represented by other way also. Here what we have shown the resultant of 2 different point resultant of whole system by considering 2 points. We can deliver it by considering equilibrium about 1 force also. How we will do? Polygon law of forces. Law of force polygon can be represented in other way also. What is that other way? If more than 2 forces acting at a point and it forms a closed loop. See, tail head, R1, R2, R3, that is R1 plus R2 plus R3 equals to 0. Means if it forms a closed loop, the resultant will be 0. Now we are coming to this new concept, that is method second method. Now we are coming to the second method. We have taken this force F2 is acting downward and the length of force F2 is 3 centimeter. We have drawn 3 centimeter downward. This is F2, and again with the help of transmissivity we have drawn F1 force here to here. Here this force is displaced up to here. This force is F1. Now the closing side, if it forms a closed loop, then resultant will be 0. This is the closing side. This is force value F. Closing side, its resultant 0. Again you have to take this length and draw in opposite direction. See, same length F. Now you draw F3 force. F3 force is acting vertically downward. F3, again F4 and F5. F5. Now what extra force should be added to the system to bring the system in equilibrium? You have to draw extra force, means extra force should be added, F5 dash. This system is represented here also. Tailhead. This is the actual, but extra how much force should be added in the system to bring this whole system equilibrium is F5 dash. Means it forms a closed loop, tailhead and tailhead. So this is the extra force, and you take reference this F5 dash and you show the percentage error. Means you draw a horizontal line, reference line here. We have taken this F5 dash theta 1 angle and this theta 2 angle. So take the percentage error in F5 minus F5 dash by F5. In direction theta 1 minus theta 2 by theta 2 dash. We are taking with respect to F5, theta 2. So this is the second method for finding the percentage error in F5 and percentage error in direction. So with this method, this type, method 1 and method 2, we can show that law of force polygon is verified, and we can draw in all this. You have to draw in chart paper, and I have one example. Yes, please. See this force system F1, one example, random example we have drawn. F1 is 300 gram F, F2 170, F3 50 gram F, F4 150 and F5 200 gram F. And we have measured all the angles with the help of protractor and pencil, that with reference line. This is the reference line, this one. With reference line, it is F1 is 147 degree, F2 is vertically downward, F3 and F4 44 degree angle, and horizontal, and F5 is 50 degree, and from here to here is 130 degree. Now using same concept, you draw the polygon, and we have a scale down. Here also a scale is taken 50:1. Yes, this is the reference line we have taken, and scale is 50:1. gram f equals to 1 centimeter. We have divided all this length, and again same principle of transmittivity. This force is transposed up to here, F2, F1, and resultant is R1. What R1 comes? 4.8 centimeter, and theta 1 178 degree in anti-clockwise direction. For system 2, and this is 1. F3 is 1 centimeter, F4 is 3 centimeter, and F5 is 4 centimeter. We have drawn, and we got the resultant R2 as 4.5 centimeter and theta 2 as 181 degree, and we have find the percentage error 6.25 degree in resultant and in direction as 1.68 degree. So we are what saying some certain error in resultant and direction also, and the reason for that error is friction between the pulleys. So we can confidently say that law of coarse polygon is verified.